My name is Devarashan Balan. I'll be representing Group K and we'll be presenting our assignment for PRN 2413 digital system. So our group was assigned question B, which is an 8 to 3 encoder, and this is the block diagram with 8 inputs I0 to I7 and 3 outputs Y0 to Y2. This is the truth table. Notice that at one given moment, only one input is high while the rest are low. This is because, let's say, for example, I2, it represents the decimal 2. So at a given moment, when only I2 is active, the number 2 is also active. Hence, the Y output will be 0, 1, 0, representing the binary number of the decimal 2. From this, we can get the logic expression for Y2, Y1, and Y0. It And with that, we can get a circuit diagram, which consists of 3 OR gates for 3 outputs Y2, Y1, Y0, and the corresponding inputs I1, I2, I3, I4, I5, I6, and I7. This is the Verilog code. Our module uses the name encoder 823 with a 7.0 input I, which represents the inputs, 8-bit inputs I0 to I7, and output register Y, 2.0, which represents the 3-bit output. And for this, we're using switch case, which helps for easy operation when you're dealing with multiple possible inputs. As I said before, when I0 is high, let's say for example, Y2, Y1, Y0 will be 0, 0, 0, representing decimal 0, and so forth for each input. And a default is added, which is for when the input is different from the one stated above, output will be XXX, displaying that the input is incorrect. And with that, we'll end the switch case and we'll stop with the Verilog code. Now, for the test bench, the test bench code, same as always, 8-bit input I0 to I7 and 3-bit input for I0 to Y2, and we should instantiate the unit under test UUT for encoder 8 to 3. And with that, we begin the test and put each possible input from I0 to I7, which is high one after the another. And we also put 2 invalid inputs, where none are high, and also more than 1 is high, and that will end the test. And now it is time to run the code. As you can see, we have our test bench code right here, and our Verilog code right here. And now we shall run it. As you can see, the output shows exactly how as we wanted it. Let's say when I input 0 is active or high, the output Y equals to 0. Whereas input 1 equals high, the output Y is 0. Each one is corresponding to each input correctly. And we have two outputs here that shows X at X. This means when the input is incorrect, where in this case there's no input that is high and there's more than one input that is high. And for these two incorrect inputs, the output will be XXX. Now let us move on to question number 2. As you can see, we are given a timing diagram and we are made to create a logic circuit from it. Now there's 3 inputs, A, B, which are initially reset, and C, which is initially set, and output M. As we can notice, output M is high when the inputs A, B, C's are as follows, where A is reset and B, C are set, or A is set and the rest are B reset. Now from that, we can create the truth table, and as you can see, the output M is only high when A, B, C is 0, 1, 1 or 1, 0, 0, following the timing diagram. With that, we can move on to creating the K-map. Unfortunately, we cannot simplify the expression anymore, so the Boolean expression will be M equals to A bar BC plus A, B bar, and C bar. Now, moving on to the circuit, we have inputs ABC, 3 NOT gates, 2 AND gates, and 1 OR gates with the output M. Each are connected to one another to their corresponding gates following the Boolean expression, and we shall move on to Verilog code. Now, the type of Verilog code we use is structural modeling. That is why we have named each element in the circuit diagram. Now, for the name of our module is logic M. The inputs A, B, C, and the output M. Y is Y1, 2, 3, 4, 5 that connects all the elements, and the 3 inverter gates, which not A and A, which output is wire 1 and input A, not B, which wire 2 as output and B as input, and C with wire 3 as output and C as input. Two AND gates, which for N1 we have wire 5 as output, wire 1, B, and C as inputs, and for AND gate 2 with wire 4 as output and A, wire 2, and wire 3 as inputs. And finally, for the OR gate, we have M as the output and wire 4 and wire 5 as input. This is all following our circuit diagram. Now, moving on to the test bench. Same as first, same test bench code for our logic M circuit, ABC as inputs and wire M as output. Now let's instantiate the unit under test for logic M. And we have also declared integer I, which will be used for our for statement. Beginning the test, we use I for our for statement to run through each possible input. And with that, we'll end the test. Now, moving on to the test, we are back in the website. Here is our test bench for logic M circuit and the regular Verilog code. Now, let's try running it. As you can see, our display tries to replicate a truth table with output M only being high or 1 during the possible input that ABC is 011 or 100. This implies that the code works. And with that, that is the end of our video. Thank you very much. That is all from Group K.